2, 3, 4, 5, 6. This one is for 7. This one is for chlorine ion. Chlorine, it's having 7 electrons outside. Sodium has just one outside. If this thing should bond, it will not look like this. Look at how the bond will not look like. Here I have one. This is for Na. Then I have 1, 2, 3, 4, 5, 6, 7, 8. Now the idea of bonding is to make this one that is not complete or stable. It is only this sodium that will provide or give it, that will provide for their bonding. That is all about ionic bond. The second type of bond we look at is covalent bond. Covalent bond is not as strong as a covalent bond or ionic bond, and it means the equal sharing of electrons among combining atoms. It is mainly seen among combining atoms. It means that covalent bond means that e.g. look at chlorine atom. Chlorine should be stable whenever it is seen with but 2 below it. So if chlorine there is a gas, should be seen with 2. Whenever you see an element with 2, it's telling that element is a gas. And for it to remain in this gaseous state, it must be stable and it must have 2. It means that for this to be stable, the first chlorine has 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 1, 2. This is first chlorine, second chlorine. If they should come like this, the first chlorine will bring 1, second will bring 1 to now form chlorine gas. So therefore, this type of compound has a low melting and boiling point. They are not always good conductors of heat and electricity, and they are not also, you can't also rely on them, but they are useful based on the type of reaction that you are engaging in. The third type of bond we're looking at now is coordinate or dative bond. Coordinate or dative bond. This type of bond is with it. You can see it in this type of bond means that the two combining elements will share one charge. It is mainly seen when two elements combine and they share one charge. Dative bond. Elements will combine and the two combining elements will do so by sharing just a charge. Then this type of bond is mainly seen in ammonium ion. NH4 is ammonium. Then and this charge you see here. In some book they will tell you that this particular charge is a charge. Is a charge controlling these two compounds. This charge is controlling these two compounds. So long as this plus 1 cannot be for N, it can be for H, but can be for the two of them as combined together. Then the other one we'll now look at here is hydrogen bond. Hydrogen bond is a bond seen whenever hydrogen combined with other elements. Hydrogen bond is seen whenever hydrogen combined with other elements. Hydrogen bond is a bond we see whenever hydrogen combines with other elements. And I use this acronym to tell us where we can see hydrogen bond. We can see the bond in nitrogen, oxygen, and fluorine, but it's very strong. If you have been asked in your exam, which of the following contains hydrogen bond? If you see hydrogen combining with N, combining with O, combining with F, combining with any other element, please, it is strongest at fluorine. When hydrogen combines with fluorine, that particular compound contains a strong hydrogen bond. So O, N, and F, when they combine, they contain any type of compound you see where hydrogen combines with these three elements, it means that there's a hydrogen bond in that particular compound. And the other one we'll now look at the metallic number 5, metallic. Now metallic bond is seen in metals. Metallic bond is a bond that is seen in metals. E.g., look at for sodium. Sodium is Na. The force holding sodium or metallic atoms together is called a metallic bond. This type of bond tends to hold particles of metals together so that they can form and be called a single entity or a single unit. Is a very strong type. Is a very strong bond that is mainly located or mainly seen in only metals. And the last one I have here is van der Waals. Van der Waals force. Van der Waals force is the weakest type of force, very, very weak. Weakest force that is seen mainly in gas molecules. They tend to hold particles of gaseous substance together. Molecules of gas are being held together by a strong Van der Waals force. Now, the more the pressure is in a cylinder, the more Van der Waals force that is contained in that cylinder. Because gas molecules tend to collide and heat themselves whenever the pressure in the cylinder is very, very high. So increase in pressure, increase the Van der Waals force, and we make the molecules of the gas heat themselves and move at a very, very constant rate. Therefore, the molecules of gas, what type of motion will even gas molecules undergo? They will undergo random motion. Random motion, haphazard motion, motion anyhow. Now they are like that because of what? Because of their nature. They are free to move, they can move anyhow, and they can also move and disturb the walls of their container. It's a weak force, very, very weak force. And this force is seen mainly only in gaseous what? In gaseous substance. I think this is all that I'll be taking for now. Meet you in my next class. If you have any question, please, you can drop it below. Thank you so much.